Imagine journeying across the vast expanse of time, witnessing the rise and fall of civilizations, or even shaping the course of history. If this statement evokes a sense of intrigue and excitement, you are not alone. The concept of time travel has fascinated humans for centuries, its mystery and allure transcending generations and cultures. Our fascination with time travel is not a recent phenomenon. Long before the age of science fiction, the concept was already present in ancient texts. The Hindu epic Mahabharata, penned over 2,000 years ago, contains an account of time dilation, a concept that modern science would only come to explore millennia later. In this ancient tale, King Raivataka Kudmi travels to meet the creator, Brahma, and upon his return, he discovers that many ages have passed on Earth, a clear instance of time dilation. Time travel has also left an indelible mark on literature and pop culture. From H.G. Wells' The Time Machine to the iconic Back to the Future series, the possibility of jumping through time has captured our collective imagination. These stories allow us to dream of a future where we can revisit past mistakes, meet historical figures, or even witness the dawn of humanity. But is time travel merely a product of human imagination, or could it be a scientific reality? The answer lies in the realm of theoretical physics, a field that has given us mind-bending concepts like quantum mechanics, black holes, and Einstein's theory of relativity. Indeed, it was Albert Einstein who first introduced the concept of space-time, a four-dimensional fabric that intertwines the three dimensions of space with the one dimension of time. This groundbreaking theory revolutionized our understanding of the universe and set the stage for future explorations of time travel. As we delve deeper into the past, we encounter a man whose theories revolutionized our understanding of time and space. Enter Albert Einstein, a man whose name is synonymous with genius. This brilliant physicist introduced us to the theory of relativity, a groundbreaking concept that forever altered our understanding of the universe. Einstein proposed that space and time are not separate entities, but rather intertwined into a four-dimensional fabric known as space-time. Now let's delve a little deeper. Einstein's theory of relativity is actually composed of two parts: special relativity and general relativity. Special relativity, introduced in 1905, states that the laws of physics are the same for all observers, regardless of their state of motion or where they are in the universe. This theory also postulates that nothing can travel faster than light. A decade later, Einstein presented general relativity, an extension of special relativity. This theory suggests that gravity is not a force, as Sir Isaac Newton proposed, but rather a curvature in space-time caused by mass and energy. Now, what does this have to do with time travel? Well, it's all about time dilation. According to Einstein, time is not absolute and can vary depending on speed and gravity. The faster an object moves, the slower time passes for it. This is the concept behind the famous twin paradox. If one twin travels near the speed of light while the other stays on Earth, the traveling twin would return younger. This might sound like science fiction, but it's real. Experiments involving atomic clocks on airplanes and satellites have confirmed time dilation. Time truly does slow down the faster you go, or the closer you are to a massive object. Einstein's theories opened up a realm of possibilities, including the idea of time travel. However, his equations also suggested that traveling back in time might require something called negative energy, a concept that remains theoretical. Einstein's theories opened up a realm of possibilities, but it was another brilliant mind that suggested a practical approach to time travel. Imagine a tunnel through time and space, a shortcut that could take you millions of years into the past or future. This notion is not just a figment of science fiction, but a concept deeply rooted in the realm of theoretical physics, the concept of wormholes. Wormholes, as the name implies, are hypothesized tunnels or shortcuts through the fabric of space and time. They could, in theory, link vastly separated regions of the universe, making interstellar travel possible in the blink of an eye. But it doesn't stop there. If wormholes can bridge distances in space, then why not moments in time? This fascinating possibility was brought to light by a renowned theoretical physicist, Kip Thorne. Thorne's work on wormholes and their potential as time machines has been both groundbreaking and contentious. He proposed that if one could stabilize a wormhole with some form of exotic matter, it might be possible to traverse it, effectively traveling to another point in time. However, this idea is not without its controversies. The existence of wormholes is purely theoretical, based on the equations of Einstein's theory of general relativity. No one has ever observed a wormhole, let alone travelled through one. Furthermore, the concept of exotic matter required to keep a wormhole open is also highly speculative. And then there's the issue of paradoxes. If one could travel back in time, couldn't they change the course of events, creating a paradox? This is one of the many questions that make time travel a tricky subject. In addition, the energy requirements for creating a wormhole, let alone stabilizing one, are astronomical. Some estimates suggest it would require the energy equivalent of a star. Despite these challenges, the concept of wormholes as potential time machines continues to captivate scientists and enthusiasts alike. They represent a tantalizing possibility, a shortcut through time, a gateway to the past or future. While wormholes offer a tantalizing possibility, there's another theory that suggests time travel could be closer to home. What if time travel doesn't require cosmic shortcuts or spaceships traveling near the speed of light? Just let that sink in for a moment. As we delve into the world of quantum mechanics, we find ourselves in a realm where the rules of classical physics are thrown out the window and the seemingly impossible becomes possible. Quantum mechanics, the theory that describes the behavior of particles at the smallest scales, introduces a concept called quantum superposition. This principle suggests that a particle can exist in multiple states simultaneously until observed. Yes, you heard it right. A particle can be here, there, and everywhere at the same time until we decide to take a peek at it. It's like Schrödinger's cat, both alive and dead at the same time until we open the box to check. But how does this relate to time travel, you ask? Well, let's consider the idea of quantum superposition in the context of time. If a particle can exist in multiple places at once, could it not also exist at multiple times? This is where our journey into the quantum realm becomes a journey through time. Some physicists suggest that time itself may be in a state of superposition. This means that theoretically, all moments in time exist simultaneously until observed. It's a concept that turns our understanding of time on its head, instead of a linear progression from past to present to future. Time could be a vast ocean of moments, all happening at once. However, before we start building our quantum time machines, it's worth noting that this is purely theoretical. Quantum mechanics is a field filled with uncertainty and paradoxes, much like the concept of time travel itself. And while it offers a new and exciting perspective, it's still a long way from providing a practical solution for hopping through time. Quantum mechanics offers a mind-bending approach to time travel, but what does the latest research say? As we explore further, we may discover that the future and the past are not as far away as they seem. Time travel remains a captivating mystery, but recent discoveries have brought us closer to understanding its complexities. The enigmatic world of quantum physics, where particles can exist in multiple states simultaneously, has been instrumental in pushing the frontiers of our knowledge about time travel. One of the most intriguing advancements is the concept of quantum superposition, which allows a particle to be in two places at once. Imagine applying this to a macroscopic level. Could we exist in two time periods simultaneously? Quantum mechanics seems to suggest so, adding a thrilling dimension to our understanding of time travel. Recent experiments have also unveiled the phenomenon of quantum entanglement, where two particles become mysteriously linked no matter the distance between them. The state of one instantly affects the other. This seemingly instantaneous communication across vast distances could, theoretically, defy the constraints of time. Moreover, the study of black holes has furthered our grasp on time dilation, a concept derived from Einstein's theory of relativity. Observations of stars orbiting near the event horizon of black holes have shown time slowing down, reinforcing the idea that time travel into the future might be possible. In the realm of wormholes, researchers are exploring whether these shortcuts through space-time could be stabilized, potentially enabling faster-than-light travel. Theoretical physicist Kip Thorne's work on traversable wormholes has sparked fascinating discussions about the possibility of time travel. But it's not all about the cosmos. On a more earthly level, the development of quantum computers could open up new avenues for simulating time travel scenarios, providing invaluable insights into the nature of time itself. While we may not be packing for a trip to the Jurassic period or the distant future just yet, the journey to unravel the mysteries of time travel continues, promising fascinating discoveries and insights along the way.